All right, here we go with dot products. So a dot product is actually very easy to do. So if you have a vector, the first one I'm just going to call x1 comma y1. And then for dot product, you make a little tiny open circle like that. So that means dot product. And our second vector is going to be x2 comma y2. Then you multiply the x component with the x component. You multiply the y component with the y component, and then just add those together. So it'd be x number 1 times x number 2 plus y1 times y2. Simple as that. So for example, if you have the vector 2 comma 7 and then dot product with negative 3 comma 5. So multiply the x with the x, so that's going to be 2 times negative 3 plus the y and the y, 7 times 5, and this is going to be negative 6 plus 35, and that is going to be 29. It's as easy as that. So you're starting with two vectors. When you find the dot product, you get just a number. When talking about numbers, they're referred to as scalars. The reason for the word scalar is if you have a vector, let's say that's the vector u, and then you want to scale it up. You want it to be 3 times longer. So you would need to multiply by 3, and that would make it go the same direction, but it would be 3 times longer. So you scaled it. You made it a scale 3 times as bigger, 3 times bigger. So this little 3 right there would be called the scalar. Now, it turns out that this simple process actually has a lot of applications. One comes in, very useful one. If you have a vector like this, let's say this is vector A, and then you have a vector like this is vector B, and then you want to know what's this angle between them. Well, you could then make a triangle and do the law of cosines and do a bunch of math, and you'd eventually get this, that cosine of theta is equal to, you take the dot product of the two vectors, you divide by the length of each vector, and then at the end, all you need to do is take cosine inverse of both sides, and you can find the angle. So for example number 2, find the angle between these two vectors. So how about 2 comma 1 comma negative 5? So it can be done in 2 dimensions or 3 dimensions. And 4 comma 3 negative 2. All right, so the setup is cosine of theta equals, and now you do the dot product. So 2 times 4 is 8, plus 1 times 3 is 3, plus negative 5 times negative 2 will be a 10. And now find the length of each vector. So square each component. So this would be a 4, a 1, and a 25. This would be a 16, a 9, and a 4. Or in other words, cosine of theta is equal to, let's see, that would be 11 and 10 is 21. This would be a 5 with 25 is the square root of 30. And this one would be 13 with 16. That's 29. And then do cosine inverse. So it's going to be cosine inverse, and I'm working in degrees right now. You do need to read the directions on the homework and see if they want degrees or radians. And then divided by, and to save myself a little bit of typing, I'm just going to put 1 square root, and inside that square root is a 30 times a 29. And so that is 44.605 degrees. That's the angle between them. Now, looking at this formula right here, what if the dot product was equal to 0? So the length of A and the length of B could be whatever. If you have a 0 on the top, then it equals 0. So if the dot product equals 0, it's going to say cosine of theta is equal to 0. And then do cosine inverse of 0, and you'll find that it's 90 degrees, or in other words, perpendicular. So that is an important fact. So the dot product of two vectors, whether in 2 dimensions or 3 dimensions, equals 0 if and only if the two vectors are perpendicular. So the angle between them will be 90 degrees. Sometimes instead of using the word perpendicular, the word orthogonal is used. Now the reason for this is, if you take the word perpendicular, it literally means that the two lines are touching, and where they intersect, this is 90 degrees. Well, with vectors, it could be that they both go from the origin and they're perpendicular. So this is 90 degrees. But it could be that, because you can place the vectors wherever, it could be that one vector is right here and the other one is right here. So technically they're not perpendicular because they're not actually intersecting, they're not touching right here. So then we have the more general term orthogonal, which means, well, if you extended the direction of this one and you extended the direction of this one, then you would have perpendicular lines. So just translate it. Whenever you see orthogonal, just think of the word perpendicular. Now there's another important idea that uses the dot product, and that is called a projection. So imagine that you have, I'm going to start off with a simple example. Suppose that you have one vector that's going like this, horizontal. And then another vector is going like this. Now, it could be that this represents, you're going to be dragging something along the ground. And because this is a long vector, that means that it's something pretty heavy. And then you're going to be pulling on it, and because you're not laying on the ground, you're going to be pulling on it. It could be like a wagon, and then this could be the handle of the wagon. So you're going to be pulling in this direction. It's not quite enough that you're going to pull this off the ground because this vector is bigger. But some of your energy is going to cause it to go this direction. How much of your energy that you're pulling up like this, how much is it going to cause it to go in this horizontal direction? So that's the projection. Yet another way to look at it is, imagine that the sun is right here, right above it. And then that causes the shadow to go straight down. Then how much is this part right here? Now there's two pieces of information. One would be what's the length of this red segment right here, and the other would be what's the vector. So let's start with, let's say this is vector B, and this is vector A. And what we're finding is called the projection of A onto B. And when I say the projection of A onto B, that means look at this red part right here as a vector. And what vector is that? So first of all, we abbreviate it and just say projection like that of A onto B. So the A is the top one, the B is the bottom one. The A is the top one, the B is the bottom one. And it goes like this. Take the dot product, the all-important dot product. Then you divide by the length of B. And that part gets squared. So this is basically making a fraction because this red part is just a fraction of all of B. It's not the whole thing. It's just a fraction of it. Then you multiply that fraction by vector B. And what it does is it takes vector B, keeps it going in the same direction, but because this is a number, a fraction, it's then going to shrink it down like that. And then you would have this red vector right here. Now, if you only wanted to know the length of it, you could then take each component, square it, add them together, put it in the square root, etc. Or you could use this little shortcut. So the length of that red vector is called the component, or it's abbreviated as comp for component of A onto B. And that's basically the beginning part right here without the square. So that would be the dot product and then divided by the length of B. So let's do an example. So for example, suppose that vector A is 3, 2. And vector B is 8, 0. So just look at a quick graph real quick. So 8, 0 would mean go over here to 8. And then this on the ground is vector B. So there's B. And then A would be, so let's say right here is 3, right here is 2, and then this is vector A. So I'm going to use the formulas that I just went over, but with this one, because I made up a simple example, basically you could look at this as a right triangle. So I could have this is vector A, and then drop a perpendicular down. And this bottom side right here, that would be 3. And this side, that would be the same as this, so this is 2. So actually, I didn't even really need to do this part because then you can see right here, the length of this is 3, so that means that the component of A onto B is equal to 3. And then as a vector, that would be the projection of A onto B. Now write this as a vector. That would be the vector 3, 0. Okay, so this one I didn't even need the formulas, but now let's do this problem with these formulas. So I'm going to do this part first, and I should get this as the answer. So the projection of A onto B. So here's how I remember the formula. Projection, you need to know the dot product. So that would be 3 times 8, so that's 24, plus 2 times 0. And then because B is on the bottom, that goes on the bottom right here. So find the length of B and square it. So that would be 8 squared plus 0 squared that goes inside the radical. And then the formula also has that you have to square that length. And then multiply that by B. So 8, 0. So let's see, 24 plus 0, I can do that without a calculator. And then this would be 64. You square it, that's, or square root it, that's an 8. You square it, that's a 64. So it's basically saying you need to find this fraction of the original vector. So that's what I was saying. You're taking this vector and then you're making a fraction of that so that it squishes down to be this vector. Well, let's see, how much is 24 divided by 64 as a fraction? That's 3/8. So I need 3/8 of the vector 8, 0. Well, when you multiply the 3/8, then these 8s are going to cancel, leaving a 1, and then it'll just be 3, 0. So this is correct. Now the component is going to be the length of that vector. So the component of A projected onto B would be the square root of 3 squared plus 0 squared. So that's going to be 9, and the square root of 9 is 3. So that part is correct. Or I could use the formula, the component of A onto B is equal to, so now I want to use my component formula using this guy right here. So that would be the dot product of the two vectors. I need to be able to see the two vectors. So that would be 3 times 8 plus 2 times 0. So that would be 24 plus 0. And then it gets divided by the length of B. And that would be the square root of 8 squared plus 0 squared. For the component formula, it doesn't have this square. So it's just the square root. So let's see, this would be 24 on top. And then this would be 8 squared is 64, but then you take the square root of that, so it's 8. And so sure enough, it's 3. So now I've gotten the same answer, doing it several different ways. I'm pretty sure that I got it right. Now let's see if the homework looks anything like that. So this vector, u is equal to, I prefer to write it in the component form, so I'm going to do that, 7, 2, radical 3. And v is equal to -7, -2, wait, I'm seeing a pattern here. So these vectors are pointed in the opposite direction, because they're the same numbers, but this one is negative of this one. So that means that they're going like this. Find the dot product of u and v. So that's part A. So they're saying v dot product u. The order doesn't matter. So that would be 7 times -7, that's -49. A 2 times -2, that's -4. And then a radical 3 times a radical 3, that's going to be 3, but with a minus. So that is 49 and 7 is 56, negative 56. Okay, that's the first part, negative 56. Well done. Now find the length of each one. So they're basically having you do all the parts. Next, find the length of u and of v. So the length of u would be the square root. So 7 squared is 49. 2 squared would be 4. And radical 3 squared would be 3. So that would be, oh, it's 56. Strange coincidence. Square root of 56. And because these are the same numbers except negative, when you do the length, you're going to get the same thing. Because when you square the negatives, it will become positive. So it's going to turn out to be the same thing, the square root of 56. Oh, it says simplify your answer. So can this be simplified? Let's see. 56, could you factor out a 4? Yes, it's 4 times 14. So that would be 2 radical 14. All right, so that's this part. That's part A. Find cosine of the angle between them. All right, so cosine of the angle between them will equal. So on the top, you do the dot product. That was this part. And then you need to divide by each length. So that would be 2 radical 14 times another 2 radical 14. Now it said find cosine of the angle, but it didn't say to find the angle itself. But it does say simplify, so we need to simplify this. So how much is a negative 56 getting divided by 2 radical 14? And instead of typing it again, I could just say it's squared. And it equals negative 1. So cosine of theta equals negative 1. So they're saying find cosine of the angle, so they're saying just find that negative 1. But if you find the angle, cosine inverse of negative 1 is equal to 180 degrees. And then that is because they're going in opposite directions, so the angle between them is 180 degrees. Now I need another piece of paper. So for this part, find the component of u in the direction of v. So that is, find the component of u, v. And scalar just means you're going to get a number at the end. Okay, so that goes, you need the dot product, and then whatever's down here goes down here, and you need its length. So we actually have the parts that we need because we already did the dot product. So that's equal to negative 56. And then the length of v is square root of 56, or 2 radical 14. And then that would equal negative 56 divided by parentheses 2 square root of 14. So it's negative 7.483. So there's the component. Now what about the projection? So the projection of u onto v, so that is the dot product, and then it's divided by the length of v gets squared, and then it's times v itself. So it's very similar to this. I just need to square this and then also put the v vector. So that would be negative 56 for the dot product, and then 2 radical 14 gets squared for that square, and then vector v, which is negative 7, negative 2, negative radical 3. So how about this part? Negative 56. Oh, you know what I could do? I could just screen grab this and then square it. Oh yeah, equals negative 1, same as last time. So it equals negative 1, which means that you're multiplying this negative 1 through. So that would be 7, 2, square root of 3. Or you could write it with I, j, and k. So 7i, 2j, and radical 3k. All right, what else have we got? So before I go into the next one, just real quick, I drew the projection like this. The most obvious example is you have a horizontal, then you're pulling up on this way, and then you go straight down, and the projection is this part right here. Now, projection could also happen like you could even start with the same picture, but now project this one onto this one. So basically what that means is you take the direction of this vector and you could just extend it out. Now look at it this way and project this one straight down. And so because this one was so much longer, it's actually going to go longer than the original vector. So it would then be even longer. So things like that are possible. What else have we got on the homework? Suppose you have a triangle, and here's the 3 points, A, B, and C. Find the measure of angle ABC. So I'm not going to draw it very accurately. I don't really have to. Look at, here's A, here's B, here's C in theory. And this means go from A to B to C. So go from A to B to C. So they're really saying, what's the measure of angle B? So I can use that formula, cosine of theta equals, etc. But for that, I need a vector. So I need a vector that goes like this. And I also need a vector that goes like this. So for this vector, the vector that goes from B to A, we get that by actually subtracting the points A minus B. So it needs to be the second one minus the first one. And this vector, which goes from B to C, actually comes from C minus B. So the vector BA. So that's going to actually be A minus B. So negative 3 minus 1, that's negative 4. And then 0 minus 2, that's negative 2. Now for the vector that goes from B to C. So you need to do C minus B. 3 minus 1, that'll be 2. And then negative 2 minus a 2 is negative 4. All right, now we can do that cosine formula. So cosine of the angle B equals, do the dot product. So this is going to be negative 4 times 2, that's negative 8. And then a negative 2 times a negative 4, that's positive 8. And now technically I'm supposed to also go like this. But I can already see that this equals 0 And if the dot product equals 0, that means that these are perpendicular. Okay, just for fun, I'm going to just finish this part. So it would be 16 plus 4, because you have to square each one of these. This would be 4 and 16. So cosine of b equals 0 divided by something, so it equals 0. And then that means that b is 90 degrees. Okay, two more examples from the homework. So you've got a circle. So there's a fact from geometry that they're trying to illustrate. You have a circle. And then let's say this is the diameter of the circle. Right here is the center. And then you pick a point, like wherever, right there on the circle. And then you draw this to that side of the diameter, and you draw this to that side of the diameter. This is going to be 90 degrees. So that's a fact from geometry, but they want you to prove it using vectors. Now let's see. Show that CA, so this is a vector, and it must come from, so CA comes from subtracting 2 points. And if it's going from C to A, that means you go A minus C. Well, what are these as actual points? So this is a vector. So U is a vector. What, comma, what? Well, there are no numbers on here, so I can't put it as a number. So what I'll do is I'll call it U, its x component, and U, its y component. Likewise, for V, it would be V's x component and V's y component. Okay, so what point is A? So A would mean go to the left and don't go up and don't go down. So as a point, that would be, so as a point, you use round parentheses. That would be, you go to the left, which means you went this far to the left. So negative ux. And then don't go up or don't go down, so this is 0. And then the point B. So B would be the point, go to the right by however much the x component of u says, and don't go up or don't go down, so the next part's 0. And then C as a point, well, this is coming from vector v, so that would be the point where you take v, the x component, and v, the y component. Okay, now back to this part. So this vector means you subtract a minus c. So a minus c. So that's going to be the vector negative ux, and then subtract this part, minus vx. So now we're still doing a minus c. So this minus this would be 0 minus the vy, so that's negative vy. All right, so CA is this minus this, comma. Okay, so I got this part. Now on their choices, they actually have the same thing over here. So that's good. That means I got that part right. What about CB? So C to B actually means take B minus C. So B minus, B minus C, that would be ux minus vx. And then B minus C would be 0 minus vy. So negative Vy. And then this has the exact same thing that I just got right there. This has the exact same thing. So far they're the same. Now they're saying find the dot product of those two vectors. So the dot product, CA dot product with CB. By the way, they're supposed to have an open circle right there. Anyway, pretend it's an open circle for the dot product. All right, so for the dot product, you would take this times this. So we would have negative ux minus vx times this one, ux minus vx. And then we need the y component times the y component. So then it's going to go plus. When you multiply these two, the negatives are going to be gone, and it's just going to be Vy getting squared. Now go ahead and distribute. So there would be this one times this one is going to be negative ux gets squared. Then there would be this one times this one, which is going to be positive ux times vx. Now distribute this one. That's going to be negative this times this, vx times ux. And then this one times this is going to be plus vx being squared. And then at the end, just copy down this vy being squared. So let's see, this one, these two are actually the same. So right here, this and this can cancel. So what's left is vx being squared minus, so that's this guy, minus ux being squared plus vy being squared. All right, that's where this stuff came from. Now they say it's either the length of v being squared minus the length of u being squared, or it's this cosine thing and sine of pi over 2. I have no idea why there's a pi over 2 unless they're already assuming that they're perpendicular, which you're not supposed to assume it's perpendicular, you're supposed to prove that it's perpendicular. So let's see where this last part came from. So they're saying the length of u and the length of v. So let's see, from right here. Let me get a clean paper. So the length of u would be the square root of ux squared plus uy squared. And then they said you're going to, right here, they said you're going to square those. So if you square both sides, the length of u squared equals ux squared plus uy squared. And the length of v would be the square root, so that's this one right here. So that would be vx squared plus vy squared, but then square both sides. So the length of v being squared equals vx squared plus vy squared. But with this u, it actually doesn't have, the second component is actually 0. So actually this one right here is 0. So then, if you find out what is the length of v squared minus the length of u being squared. So I'm trying to match up this and see if it makes sense. So the length of, so that would be this one, equals Vx being squared plus Vy being squared. And then minus the length of u squared, so that would be minus ux being squared. And if you look at the work I had done before, it's got Vx squared, it's got the minus ux squared, and it's got the Vy being squared, so they're the same. So with this, I now showed that that equals the length of v squared minus the length of u squared. Okay, the last part is, why did they say that equals 0? Well, this is a circle, so if you go right here, that's going to be the radius of the circle. So the length of u and the length of v, they're both the radius of the circle, so they're the same. So that equals 0. So my choice is this one right here. Well, believe it or not, we got time for one more. It's going to go fast. A gun with muzzle velocity of 1180 feet per second is fired at an angle of 5 degrees. So here's the horizon, here's 5 degrees, and it's gonna fly out at 1180 feet per second. Find the horizontal and vertical component of the velocity. That just means make a right triangle and find out what x is and find out what y is. So the horizontal component, that just means solve for x. So for this, we can just use good old trigonometry. So cosine of 5 degrees equals adjacent over hypotenuse. Or in other words, x is equal to 1180 times cosine of 5 degrees. Likewise, sine of 5 degrees, so sine would be opposite over hypotenuse. So the vertical component would be 1180 times sine of 5 degrees. And then you could type that in a calculator and they're going to round it to the nearest integer.